Yeah, sure.
Okay. We'll just wait for 2 more minutes for Kaka to join. So based on the feedback that we got in the last session, we have again, modified today's content, wherein for the first, say, 1/3 of the session, I'll give an introduction of Ethereum setup, the problems, what is changing in Ethereum, what would Ethereum be like going forward, and then we'll dive into the technical details. So we'll get into implementations like you guys had requested. So it has been tweaked to suit that.
Hey, Sunil,
Yeah,
meanwhile, Kaka is joining. Can we just have a quick touch base on the installations that you have earlier sent in the week?
right.
So there were four things that you have asked to install.
So
Uh,
actually, all of those were requested by Kaka. If you've
okay.
got very specific question, let him join and we can take it. But did
Oh,
you have any trouble doing that?
no, I just want to make sure that I have installed everything correctly. So I got all the four things installed, but
Okay.
there was no like I just want to have some instruction to verify that everything works fine, and I'm
Okay.
able to open the like Node.js and source safe whatever that's Visual Source Code, and I
Okay.
installed the with that Ethereum extension and that Chrome extension. Just
Hmm.
wanted to see how I can verify that everything is correct.
Okay. So when we get into that, maybe
Sure,
in the second half
no
of the session.
problem.
So I
Yeah.
see Kaka has joined. Kaka, would you like to, uh, you know, so I was just telling the guys what we are going to do today. In the first uh, half, we'll get onto the theory part of Ethereum, how, what is lacking currently, how Ethereum is going to change, what is the community doing, etc. And then in the second half, we'll be doing more of theoretic bit. So very quickly, if you would like to tell them what we'll be covering today. Hello?
Yeah, hi, Gagan. Sorry.
I can't hear Kaka. I'm not sure.
Kaka, can you hear us?
Hey, hi, guys.
Okay.
Can you hear me?
Yeah.
Yes, we can.
Yes.
Yeah, go ahead.
Okay, cool.
Okay. So all is
So,
good.
yeah, as Sunil just mentioned that we are having this session combinedly today. So, first half will be covered by Sunil, and second half will be covered by me. So, I'll be more on explaining you guys about the writing code for Ethereum platform in Solidity. And yeah, before that, Sunil will actually get all into the Ethereum, what is Ethereum, and what is the actual platform is, and how we can write programs on Ethereum platform.
Okay. So guys,
Sunil,
yeah.
I have a basic question.
Yes.
This Ethereum is a type of blockchain, or this is separate thing? It's not
It
blockchain.
it originated from the Bitcoin blockchain, and
Mm-hmm.
it has got some very specific features. There were some shortcomings in the Bitcoin blockchain, which a
Uh-huh.
group of developers led by Vitalik Buterin, who is known as the inventor of Ethereum, these guys listed down the problems, worked on a solution, and that solution was basically extension of the Bitcoin blockchain, which is called as Ethereum now. And it is still evolving, wherein there are certain problems that they're trying to address, certain opportunities that they're trying to address. So Ethereum is still evolving, and we will see all of that.
Okay.
Okay, so without wasting any time, let's start. So we'll be seeing these things today. What is Ethereum? What is an Ether? How to use Ethereum? The Ethereum ecosystem. What are DApps? What is a DAO? How Ethereum mining works? We'll see Solidity, the programming language for Ethereum, contract classes, functions, conditionals, inheritance, abstract constructs. So these are the implementation, the language specific details that we'll be seeing today. the various libraries, how you define variables, what are global variables, etc. And ultimately, where is Ethereum headed? So apart from all the other topics, just the future of Ethereum part, I will be covering it right after how Ethereum mining works. Okay, and then I'll hand over to Kaka, who will take you through the technical part. So just these few slides on future of Ethereum, I'll be covering it right after how Ethereum mining works, and then we can focus the session on the technical details. So we can spend whatever time we have left, and I will try to wrap up the theory part in as much less time as possible, so we get maximum time for practical. Okay. So yes, like you were just asking, what is Ethereum? Why do we need another blockchain solution? The Bitcoin blockchain was there. So why is Ethereum needed? Now, Bitcoin, like we've discussed earlier also, like normally platform comes first and then a product comes out of it. There are several products that come out of it. In case of Bitcoin blockchain, it was the reverse way, wherein Bitcoin came first and then people realized the platform is too powerful and it can be used for a myriad range of applications. So Bitcoin, like if you consider in terms of internet, it is like email came first and then you realize that platform that is backing it, the internet, can be used for a lot of things. So that is what happened with blockchain. So people realize blockchain can be used for a lot of other purposes, but Bitcoin is currently limiting it only for currency, transfers. Someone is sending a message. No, okay. So based on that, a group of developers came together and they thought, let's extend blockchain for other use cases. Now, while these discussions were happening, a lot of groups were, working in that direction. So some groups, took a specific use case, extended the Bitcoin blockchain to that particular, use case. This kept on happening until another group of developers thought, instead of, everyone writing a separate blockchain for a use case, let's make a generic platform which can support anything. Okay, that is where Ethereum came from. So the thought behind Ethereum was, we should be having a generic platform where anyone should be able to write their code, okay, based on obviously certain fixed parameters, following certain standards, etc. Anyone should be able to deploy their code on top of the platform and make a use case out of it. So that is how Ethereum came into existence. So what they had a mission statement. What the mission statement was: to research, design, and build software that, as best as possible, facilitates in a secure, decentralized, and fair manner the communication and automatically enforced agreement between the parties. Now, this is the mission statement that these guys had in mind when trying to develop a new platform that would do these things. Now, if you focus on these words that are highlighted now, so software, secure, decentralized, and fair communication. Okay, this is what any blockchain implementation offer. This is what even the Bitcoin blockchain offered. So it is a software, it is secure, it is decentralized, it is fair, and offers communication. Plus, what they wanted to extend is it should offer an automatically enforced agreement. So it should not be that, we go back to everything, how Bitcoin and blockchain came into existence, what is trust, how people would, invalidate trust, etc. So the software itself had to have the capability that there was an automatically enforced agreement if a transaction took place. So it could not be rolled back. We saw all of that, right? So that is where these guys came from. They wanted to put the logic on the platform itself. So they would deploy an application. It would have the logic. So for example, if I do a transaction, the transaction itself would have a piece of code, and based on certain criteria, it may automatically get executed. Now let's take a very simple example. I rent a home. Okay, I agree to pay the owner, say $1,000 per month. Okay, I paid for the first month, and from the next month I stopped paying the rent. And this happens normally also. I mean, it may not be that I don't want to pay him, I don't have the money or resources or whatever, right? If we could, so normally when you do a rental, you sign up an agreement in which you say, I promise to pay on X date whatever amount of money to this person. That is an agreement. If there was some way I could enter that agreement into a software and put it in the banking and finance world, wherein it would automatically get executed. So on 10th of every month, it would automatically debit my account and put that money into the owner's account. So that is what Ethereum contracts basically offer. The contracts are automatically, in software form, placed on the network, and based on a certain criteria getting met, okay, it automatically executes. So now there is no way I can willfully not offer the rent to the owner. Right now, this was a very simple use case. There are a lot of other use cases, like we saw the trade life cycle in the previous classes, right? Instead of having to rely on external inputs, I could code the logic on the contract itself. So as soon as the goods reach the port, it is scanned in a barcode or whatever, or it is IoT enabled. Okay, the transaction automatically happens. Okay, no one has to trigger it, no one has to manually sign that that the goods have arrived, etc. So this is what Ethereum aimed at, and this is what Ethereum has achieved also. So what is Ethereum? Ethereum is another open blockchain platform that lets anyone build and use decentralized applications that run on the blockchain technology. Like Bitcoin, no one owns Ethereum, open source, anyone can come and join. We will see how you can join the Ethereum network like we saw for Bitcoin. Only thing is, Bitcoin, like I said, was designed for a very specific use case, only for mining of Bitcoins and transferring, sending and receiving Bitcoins. Ethereum is adaptable and flexible. So you can create new applications, have your own use cases, and deploy it to the Ethereum platform. And obviously, there are certain challenges. We will see some problems that happened in the past. So the Ethereum team, led by Vitalik, continuously works on this, and they keep solving these problems, resolving these issues. The basic is Ethereum is based on contracts. Now, contract is an agreement between two parties, right? So code-based contracts are main building blocks of Ethereum. They are also popularly referred as smart contracts. Smart in the sense no one needs to execute the contract. They are smart themselves, that based on the predefined condition, when the smart contract was deployed, it will automatically execute. Smart contract is a phrase used to describe a computer code that can facilitate the exchange of money, content, property, shares, or anything of value. So we saw example of the music industry, right, wherein some artists are now directly releasing their music online, and it has smart code embedded in it that whenever you stream, a certain royalty will automatically go to the artist. So this is how it happens. When
Actually,
running,
one more question
yeah,
on this smart contract. Are these smart contracts are legal contract?
legal as such, no. You cannot have the government enforce it, because these things, the entire blockchain is not enforced or endorsed even in a lot of places by the government. But if you are on the network, okay, like you remain on the Ethereum network, you've got Ethereum coins, it will automatically and be enforced on you. There's no way you can control. Once a contract is placed, unless you decide you don't want to be on the network anymore, no one can do anything about it, because it's not enforced by the government. But if you are taking part on the network, then these automatically are enforced on you. No one can stop them. But if you are saying by law, no.
The reason I ask is because all of these things which you mentioned here, money, property, share, all these are legal things, right? So
Correct. So
that's the reason I just-
so when people will be indulging in these things, right? The ethers are not coming for free. Okay, unless you are a miner and have a large amount of CPU power who's mining it himself, even then it has a cost attached to it, right? So when you're dealing with ethers, it is real world money that you are talking about. Okay, if you have invested that kind of real money to buy ethers and enforcing these contracts, and you still want to do a fraud or something, I mean, we'll see how that gets tracked and what are the resolutions. But in terms of whether you can take someone to court for not paying you ethers, or the contract failed or something like that, it is outside the purview, because this is an upcoming thing. So even the regulation is not sure about what should fall under their purview, what should not fall.
Okay.
That is on the public platform, but obviously if you use the same installation in a private blockchain, you could might as well have a legal contract signed, and then everything as a smart contract on the network. Okay.
Okay.
Yeah, because okay, and when running on the blockchain, a smart contract becomes a self-operating computer program. It automatically executes when specific conditions are met. Smart contracts run on the blockchain. They run exactly as programmed, without any possibility of censorship, downtime, fraud, or third-party interference. These are the features that are offered by the underlying platform. So we know anything that is on the blockchain cannot be censored. Anyone running the node will have access to it. There is no downtime, because it is not a central server that can be that you can do a distributed denial of service attack on that, or it is down for maintenance. Nothing of that sort can happen, because there are millions of people running these nodes. So one or two people or even thousands of people going down does not matter, because there are a lot of other copies available. You cannot do fraud, you cannot do third party. I mean, no third party can come down and say this contract will not be enforced, because once it is coded in the system, it is coded in the system. No one can backtrack. Now, I keep saying this, but there is a caveat to this, and we will see when the entire ecosystem backtracked on this statement, wherein even though we say it is immutable and irreversible, they did reverse a lot of transactions for a very specific case. So we will see that. But by design, it is not supposed to do that. Ethereum's primary language is a JavaScript-like language called Solidity. But apart from Solidity, there are other things like Serpent. If you are comfortable with Python, you could go with Serpent. You've got Mutin, which is more C-like, and then you've got LLL, which is Lisp-like language. So these are the main Ethereum programming languages. Most popular of them is Solidity. The second one is Serpent. Other two I've not seen many installations, but then those two also offer all the capabilities that you could have on Ethereum blockchain. It is versatile, like we spoke about. Other blockchain implementations have a very specific purpose. They are designed only for that particular use case. Ethereum allows you to write custom code. You could have your own apps. So like a Symbian operating system from the older days, okay, Nokia, which Nokia had, you could develop very specific applications which would run only there. Compare it with Apple or Google Play Store. Anyone can come, write their custom applications, upload it to the Play Store. Everyone who is participating, downloads it and becomes to use the functionalities. So that is, the analogy that you can use in terms of Bitcoin blockchain and the Ethereum blockchain.
Hey, Sunil.
Yeah.
I have a basic question. So probably if this question is deviating from the flow, we can cover this question later. But I just want to ask so that I don't lose the thought.
Yes. Yeah.
So basically, we are talking here like you were mentioning earlier that internet. You gave an analogy of internet.
Correct.
So like when you say internet, it is nothing but an HTTP protocol based on GET, POST, request, and that HTTP is the basic building block of the internet, right?
Correct. Correct.
So when we say that we have now alternative competitive blockchain platforms, so can I assume like there is another internet which is not based on HTTP protocol, but it's some other own protocol, and that is Ethereum?
Ethereum started with the Bitcoin code base itself. right?
Oh, I see.
But
Okay.
they built on top of it. So they've built a lot of code on top of it.
I see.
Underlying cryptography and digital signatures and hashing algorithm that we saw, those remain same. However,
Okay.
now Ethereum has started to see the problems that Bitcoin blockchain have, and they have already issued some white papers and thoughts on how they are going to tackle it. We will see it in the flow,
Okay.
but it is based on the same principles, same platform, and same technology. So
Okay.
Ethereum is just an upgraded or a better version of the Bitcoin blockchain.
Okay.
Okay.
Thank you.
Yeah. So unlike the Bitcoin blockchain, Ethereum contracts can be used to build currencies, financial derivatives, voting systems, decentralized organizations, data feeds, title registries, thousands of other applications. Uh, so while all blockchains have the ability to process code, they have several limitations in terms of what a user can add. In Ethereum, it is different. Rather than giving a limited operations to the users, Ethereum allows its developers to create whatever operations they want. Okay, and they could build any applications. I mean, it is up to your creativity. Okay, but it has to obviously follow. So they have given certain hooks or API points which you can call. You can write your application based on top of that and enforce those contracts. Now, what is a contract? So option contract between parties is written as a code into the blockchain. Individuals involved are anonymous, so no one knows who it is. But the contract, it is written as contact, it should be contract. The contract is public ledger, so anyone can see what the contract was signed, and it is executed automatically. So no one has to really provide a trigger or enforce it. So a triggering event like expiration date. So like I gave the example of renting, it could be that, or it could be anything. So you take something on lease, or you like for this particular course, if we had agreed we would be doing it on an Ethereum platform, and you pay the fees right after each week, we could put it on a contract, and automatically as soon as we mark the end of session, your accounts get debited and I get paid equivalent ethers or whatever we have decided. So it could be enforced as a contract. Regulators can use a blockchain to understand the activity in the market while maintaining privacy of individual actors' positions. So it is versatile
So
in that sense. Yes.
one more question, Sunil. So
Yeah.
any transaction, especially we're talking about the money, that
Mhm.
happens only in Ether, right? In the Ethereum blockchain, is that the
Yes.
restriction, or there can be any other way of making the payment?
No, no, it is in ethers only.
Oh, okay, so it's in their interest, basically. Whoever created this platform, probably they have created with this system so that if people are using it, somebody will transact that Ether, right?
So basically, what is a digital currency? Is a token, right? Now, only when the token is transferred from one person to another or one party to another, we realize that the transaction has taken place. Okay. Now, even for non-financial transactions, you would still use that token. It would not have any value, but only when the token transfer takes place, because that is how the platform is designed, right? You realize that the transaction has happened, so you use it for tracking. Ethereum's Ether, okay, is like Bitcoin blockchain's Bitcoin. So that is one of the use case.
So when you're talking about the transfer of Ether, it's not that Ether currency, it is something else. Basically, when we're creating the app, we can just create some kind of a pseudo Ether, which transfer from one
No,
person to another person.
no. So when you're talking about the financial application, it is, I mean, in terms of transferring money, it is the actual ethers that are transported from one account to another. So
Yeah, I'm talking
okay,
about the other use
yes.
case.
So other use case, it is just tokens. You have to pay gas fee. We'll see what gas fee is. So
Okay,
for
that's
other,
fine.
yeah.
Yeah, when if you're covering that, that's in the further side, that's fine. Okay.
Yeah. Now Ether is the fuel. So basically the currency, the Bitcoin equivalent is Ether here. It is type of a digital token that powers the applications on the decentralized network. sending a transaction to the contract causes its code to execute. So for example, if I had, now in Ethereum there are two type of accounts. One is the normal account that we own, okay, which is called as an externally owned address, and the other one is called as contract address. So when we do a contract, okay, a contract account is also created and the code is with the contract address. When we do a transaction, okay, so for example, let's say a use case wherein I say, if I earn $100, okay, I will pay $10 automatically to the artist. Say I am Sony Corporation, who's released the music for Beyonce or whoever. Whenever I earn $100 from the music streaming, $10 will automatically be paid to the artist. In Bitcoin blockchain, I would have to manually do it, being Sony. Okay, whenever I receive $100, $100 or 100 Bitcoins, whatever, I would pay 10% of it to the artist. I could always renege on my trust, even though I receive 100. I would tell them that I'm not going to pay it. Do whatever you want. In Ethereum, if I enforce a contract, as soon as I receive 100, the system automatically takes that 10 and pays to the artist. There is no scope for me as Sony to disavow on my payment. So that is one. I mean, that is how a smart contract is coded on the system. So you have smart contract addresses and you have externally owned addresses. So contracts can store data, send transactions, and interact with other contracts also. So you could have a more complex use case wherein one contract, as soon as the condition for one contract happens and that the code for that contract executes, it can call in several other contracts, creating a chain of contracts to be met before the transaction can be assumed to be complete. These are the denominations. So most of the denominations are named after popular people who have added some value to the computer space, basically.
So Sunil, also one basic question. So these days we are hearing that a lot of companies are launching their own blockchain, like IBM has launched their Hyperledger, and then recently, just this week, Oracle has launched its own blockchain.
Correct.
So can we consider that those blockchain and like kind of like Ether blockchain? Just only thing is that they are public. They are private blockchain.
They are private. They are private, but we don't know the underlying platform that they've taken. So like we have Bitcoin blockchain, we have Ethereum. There are other certain platforms available like multi-chain. You have Yobi chain. So there are lot many other implementations available. Hyperledger itself is a different platform, so we don't know. I mean, what these private players are going with.
Okay.
But again, for most of the blockchain, the concept remains same. Only thing is, instead of proof of work, they will rely on proof of stake, and instead of permissionless, it would be permissioned. Not even proof of stake. In case of permission, they would not go for anything. I mean, it would be that the nodes that are decided to be the signing parties, once they have validated the transaction is accepted by everyone else to have taken place.
Okay.
So you can see the lowest denomination available is V, named after VD, who is considered one of the proponents of this digital money. Then you have Qui, which is named after Charles Babbage. You have V, which is named after Lovelace. Similarly, you have Microether, which is named after Nick Szabo. So all these, if you see Ether, it is 1 e raised to 83, so 18 zeros followed by that. So you can say the lowest denomination is 0.1801. So that is the level to which these denominations can go. Okay, so we've seen what Ether is, we've seen what Ethereum is. If you want to purchase Ether, how can you get? So in order to obtain Ether, you can either become an Ethereum miner, the most difficult way. But again, you don't have to do anything. Become a miner, be on the network. If you are able to mine a block, you get an Ether and you get 5 Ethers. So like in blockchain, Bitcoin blockchain, you used to get 12.5 Bitcoins for mining one block, which usually happens every 10 minutes. In Ethereum blockchain, block is mined approximately every 12 to 14 seconds, generally accepted to be 12, but network congestion and different things, sometimes it is 12 to 14 seconds, and you get 5 ethers. The other significant differences in Bitcoin blockchain, like we saw the concept of halving, wherein every 2016 blocks the reward gets reduced to half. So after next 2016 blocks, those blocks are mined, you would have the reward reduced from 12.5 to 6.25. So in Ethereum, there's no such concept. It is kept fixed at 5 ethers. Whenever you mine a block, you get a fixed 5 ethers. Trade other currencies for ether using. So the other option is,
Sunil,
yeah.
Sunil, two basic questions on this mining. First thing is that you did mention that it will be mined in the 12 to 14 seconds instead of like
Yes.
10 minutes.
Correct.
So what is the reason? Because there, in the case of Bitcoin, I think that the complexity to generate that code and the hash and nonce and other things, that is the reason it used to take 10 minutes and at least 3 people need to validate it. All those concepts are there.
Correct.
Is those concepts still
yes,
here or is
concept
compromised?
Concept is still here. Only thing is the algorithms have been changed. Plus, Vitalik thinks that, he also thinks he's very vocal on Reddit and these platforms. So if you read on them, he says Bitcoin is wasting a lot of electricity and computing power doing things that is not really required. Okay, so there are better ways to do it, and that is how the Ethereum algorithm has been built, wherein, so when we talk about blockchain, Bitcoin blockchain, we know that earlier you were able to mine with normal computers, then GPUs, then ASIC miners, and these stuff have come, right? Vitalik believes that it should be, in fact, difficult to mine using dedicated hardware. So currently GPUs are the best level. Okay, so you could mine using your own computer or you could mine using GPU. Mining using your own computer, you would not get much results, but you could still do it. With GPUs, you are good enough with Ethereum. You don't have to have specific ASIC miners or AND miners, as we saw in the last session. So he believes that we should not be using unnecessary electricity and mining power in doing the validation of proof of work. And based on the same thought, he's also come up with a thought that instead of having proof of work, Ethereum should soon move towards proof of stake. So we will see that how that will help. So that is why the timings here are approximately 10 to 12 seconds, or 12 to 14 seconds. But still, even 12 to 14 seconds are not good enough for online transactions. We know how Visa and MasterCard operate. So there is still scope wherein these guys are trying to better it. For Bitcoin also, there's a team working. There was, I think it has already happened. POC has already happened. It is called as the Lightning protocol, Bitcoin Lightning protocol, wherein you could get transaction confirmations in few seconds, very minimal time. Obviously, the security or the complexity has been reduced. It is still being tested out, but the aim is to make it comparative to Visa and MasterCard, so these applications could be mainstreamed as opposed to being used by few people currently. So that work too is going on. Ethereum is also a leader in that space. We will see what they are proposing.
Okay. One more question. You mentioned that when somebody mines the ether, they will get 5 ether, and but in the case of Bitcoin, they were getting some ether, and then it was halved and other thing, and there is a limited quantity of Bitcoin is available. After I think certain years, there will not be any Bitcoin will be available. Yeah,
yes, 21 million.
but
yes.
21 million. But here in this case, Ether, is that the similar limitation applies? Like there is a fixed quantity of Ether, and after certain time it will not be available in the future.
In fact, going forward in the future, there would be no concept of mining, is what Vitalik proposes. So he wants to get rid of this entire thing while maintaining the security and the cryptographic aspects of it.
So has he fixed any number of Ether? Like these are the only number of Ether which is available?
No.
Okay. So at this point, there is no such proposal, and it might enhance in the future. Okay.
Yes.
Got it.
And very soon, because they have already proposed the algorithm that they're going to use, and it is out in the public space. Very soon, they would make the transition from proof of work to proof of stake.
Okay. Got it.
So the other option is trade other currencies for Ether. So you buy Bitcoin, okay, and then trade that Bitcoin to get Ethers, because not many exchanges are selling Ethereum directly. Though in the last, towards November 2017 to now, there have been a couple of exchanges that have started selling Ethereum directly. But for most exchanges it is, and for any other coin for that matter, okay, you cannot go ahead and buy a coin directly. You buy Bitcoin and then you trade it for that amount of that particular coin. So you want to buy, for example, LTC, or you want to buy Ethers, you buy BTC and then exchange the corresponding BTC with the person who has Ethers or with these exchanges. The other is you could those are the options that are available for Ethers. On browser, you could have MetaMask, or you could have Mist Ethereum GUI wallet that you can use to store. There's this site called Shapeshift. It is like a tongue twister to me. Shapeshift, which you can use. So you have currency, you have a particular coin. Shapeshifts allows you to transform it without having to buy it or sell it to anyone else. You could do it on Shapeshift itself. You have BTC, you want to convert it to equivalent Ethers or other currencies, you can do it on Shapeshift, having an account on Shapeshift. Now we have talked about gas. We have talked about Ether. We have also touched base gas. Gas and Ether are not the same things. Okay, so Ether is the underlying currency. Gas is the amount of transaction fee that you are willing to pay to the network or to the miner who would pick your transaction and process it. So unlike the Bitcoin blockchain, wherein you push your transaction and it remains on the network, and whoever is preparing the next block will automatically pick the transactions from uncommitted list of transactions and mine it. Here you also you show your intention that you are ready to pay X amount of gas as transaction fee if a miner processes your transaction. So if you feel your transaction is very urgent, needs to go through in the next block, you specify a higher amount of gas. Okay, so when a miner sees that for this particular transaction I'll get paid more in terms of the transaction fee, he picks it up and processes it earlier. If you feel your transaction is not that urgent and you can wait for it, you specify a lower amount of gas. So when the network is busy, obviously no one is picking up your transaction, but when there are not many other transactions to mine and a miner sees that a transaction with lower fee is available, but I've got no other work, so might as well do it, that transaction gets picked up. So gas is the transaction fee. Now in like we know, all the currencies are very volatile, okay, because these currencies trade on these exchanges. If we were to equate gas and Ether, you realize that there could be a very big problem. For example, Ethereum is trading at say $700 now. There is a massive investment come from investors, and the coin price goes up to say 1200 or 1500, whatever, right? Now if you were to pay the transaction fee based on the price of the currency, it would be very unfair and you would never be able to decide how much to specify in terms of gas. So that is why there is a mechanism kept wherein the price of gas remains constant. So the available gas remains constant. Whenever the coin price goes high, okay, too high, the gas is adjusted. The amount of gas that would be needed to execute the transaction is adjusted automatically in the platform. So for you as the user specifying the gas, the transaction fee for you remains more or less constant. It does not move with the fluctuation of the currency. So as it is written here, gas is supposed to be constant cost of network resources by utilization. So you want the real cost of sending a transaction to be always same, more or less always same. I mean, a little bit here and there, but normally, like you go to a bank, they will tell you it is $10 for this particular transaction per, say, 10,000 currency that you're sending. Now, because the US dollar does not fluctuate that heavily, okay, if say you give the instruction in morning and in the night that debit happens, uh, the transaction fee that they had quoted would remain same. I mean, more or less same if you are paying, say, in a foreign currency. So for example, if you are paying from India, the price quoted was $10. Morning price, normally banks don't do it, but let's assume that the price quoted in morning INR to USD was 66.5. By evening, when your transaction was actually processed, the currency price was 66.4. That is even, I mean, those kind of value swings, okay, even if it happens, the currency is not that volatile. But if it were to happen in the crypto space, there have been days wherein within few hours the currencies have doubled or have halved their value. So you cannot have that. That is why we want the gas price to be same. So instead, we issue Ether whose value is supposed to vary, but also implement a gas price in terms of Ether. So if price of Ether goes up, the gas price in terms of Ether should go down to keep the real cost of gas same. Okay, and that is controlled by the network. So with gas, there are multiple terms associated: gas price, gas cost, gas limit. So it is not that you can specify any amount of gas that you want. It should not be unfair to the other transactions. So there is limit and gas fees. The main principle behind gas is to have a stable value for how much a transaction or computer across the Ethereum network should cost. So that is why you want to have it constant. Gas cost is a static value for how much consumption cost in terms of gas, and the intent is that the real value of gas never changes. So this cost should always be stable over a period of time. Gas price is how much gas costs in terms of another currency or token like Ether. So to stabilize the value of gas, the gas price is floating value such that if cost of tokens or currency fluctuates, then the gas price automatically adjusts itself to the same value. The gas price is set by the equilibrium price of how much users are willing to spend and how much of processing nodes are willing to accept. Okay, so it is a safe equilibrium between that, how much you want to pay for a transaction and how much the nodes are, the minimum that the nodes will accept to do a transaction for you. Gas limit is the maximum amount of gas that can be used per block. Okay, so per block, that is the maximum gas that can be spent in mining a block. How it is derived, it is considered the maximum computational load, transaction volume, block size of a block, and miners can slowly change this value over time. Gas fee is effectively the amount of gas needed to be paid to run a particular transaction or program. So in a contract, there are a lot of steps. So for each step to run, the miner will do certain computations. I mean, we will be using the resources of the miner, right? So for each step that he performs, he gets paid certain gas fee. So gas fee of a block can be used to imply the computational load, transaction volume, or size of the block, and they are paid to the miners. Now we'll just see in some and read about some DApps that are popular. DApps
So,
basically.
Sunil, one clarification on this gas. So earlier you mentioned that it takes 10 to 12 average second to process and create a block in Ether. Now, this concept of Ether, what will happen that concept of gas, what will happen that it will not be constant, right? For some, it might be transact in the 2 seconds, and some it might 10 minutes or hour also, right?
No. More time, yes. Basically, like in blockchain, we had a limitation that the network readjusts itself, that a block will be mined only every 10 minutes. Okay. Similarly, here it is kept at 12 seconds. So if there are a lot of miners in the network, okay, automatically the difficulty will be increased, okay, for this particular proof of work algorithm, so that when the difficulty increases, you will be able to mine lesser blocks. If there are lower number of miners available for doing mining and the transactions are high, then the difficulty would be reduced so that they are able to meet mining of a block in that 12 seconds. So that is irrespective of that. Mining will always happen in that. I mean, a new block generation will only happen in that time duration. It will take that time duration.
No, but then what is the
Obviously,
purpose?
yeah, correct.
That?
So yeah, so block will get generated in that, right? Now, for example, there are 10 lakh transactions pending, okay, and the block that is being proposed can hold only 10,000, okay. Now, if I'm paying very low gas fees, then obviously no miner will pick my transaction for that 10,000 transaction that he's preparing, because he will take the top 10,000 transactions that are willing to pay the most gas fees, okay. And when he prepares a block, it will take him 12 seconds to do all the computations and prepare that block and relay it on the network. So the time remains same. Only thing is which transactions gets picked in that block are decided by the gas. So that is the importance of gas.
No, so that's what I'm asking, that when somebody is doing the transaction, the minimum will remain that 12 seconds.
Correct.
But maximum it can go up depending on how many transactions gas.
Correct.
Right.
Yes. So you sign up on the network today and you specify a ridiculously low gas amount, you will see that it will keep lying in the network. No one will pick up your transaction. So it will remain in the pool of uncommitted transactions. Your transaction will never get confirmed on the network.
Okay, got it. Okay. So Sunil, what is the solution for that? How will I know how much gas I need to pay? So that
the information, I mean, the current fees, etc., that is available on, like we saw for Bitcoin blockchain and blockchain.info. Similarly, for Ethereum also you have a similar site. You could always go there and check what is the fees currently being paid, and you could specify it. So the flexibility is given to you. If you don't feel your transaction is very important and needs to go away immediately in the next block being mined, you can specify a lower gas fee. Obviously, it should not be so low that no one is ever going to accept it.
No. My question is that assuming there are three types of fees, $10, $20, and $30 in terms of fee or Ether, whatever. So assuming I'm giving $10 to Bank of America, at least I get confirmation that by 3 days this transaction will be done. But if you are paying 22 days, if you are paying $30, in the same day it will be done.
Correct.
Okay, now coming on.
So now, I got your point. Got your point. Let me finish. Okay. So here, with $30, it will be done immediately. $20, it will take you 2 days. $10, it will take you, say, a week. Say they give you a flexibility to pay anything between 0 to 30. You tell them I will pay only 1. Okay. Now for 1, they have not given you any guarantee. They say if my servers are available for free on a Sunday night where no one is doing any transaction, and I am anyways running the cost and paying the cost of running those servers, I might take this $1 and process your transaction. But if I have other transactions which are paying me more than $1, I will still not say no to you, but your transaction will keep lying until I am free, so that it makes sense for me to accept that $1 and make your payment, make your transaction. So as simple as that. Similarly in cash terms also, if you pay me a ridiculously low fee, I will not take it unless I've got no other work to do and I'm still spending that time on the network. Then I might as well take that transaction. But it is never going to happen, because there are other transactions coming which will be offering me higher fee, and I will process only those.
So the thing I wanted to hear means there is no any time limit.
No.
Okay.
So these are some of the distributed apps, decentralized apps that are available on the Ethereum. These are famous. I mean, not famous as such. These are the DApps
So,
which have paid.
sorry, Sunil, just one more question before going on the apps.
Hmm.
So why not Ether? Means if I have to pay something, as like in dollar, everything is going on.
Mm-hmm.
So if I'm doing some service, I'm taking in dollar, paying in dollar. Then what is the need of that gas basically? Why
To keep
currency?
the transaction fee constant, right? Like you go to a bank, they will tell you a fixed transaction fee. It cannot happen that I tell you a transaction fee of 2 ethers, but the price of that 2 ether changes arbitrarily. Like these, I mean, the ether is transacted on these exchanges, right? So it is like like the price of a stock, but with much more volatility, right? So ether could be trading at $300 at 8 in the morning, and by 10:30 it could be trading at $500. So it is unfair to others on the network who are doing their transactions at 10, because it is being treated as a commodity. Transaction fees cannot be in terms of commodity, so that is why they've kept it as a fixed gas price. So ether can be volatile and can be traded, but the transaction fee that you have to pay in terms of gas is maintained at the same level.
Okay, I got it.
So we've got VFund, like you have Kickstarter. So if anyone has experience using Kickstarter or any similar platform, there are a lot of other platforms available on the same concept. They let you raise funds, okay, for your startup, for your company, but they will charge a good amount of it. So like 5% of it, or some even charge up to 10% of it. So it is unfair to the person who is raising the funds, because it is all his hard work uh, for which people are willing to pay funds. But then again, these people are providing you the platform to raise funds. That is why they are charging you that fee. So VFund is an open platform for crowdfunding campaigns that leverage smart contracts. It enables contributions to be turned into contractually backed digital assets. Now, what happens in Kickstarter is you pay for a certain startup. They say that they will be, delivering this and that by whatever their project plan is. They get the money and nothing happens. Okay, so you have made the donation in good faith, in receiving something in return, a product or maybe stake, etc. But there is no tracking for that. But in VFund, you could have a smart contract embedded, wherein the other party also agrees and is part of the network, and you as the investor, you get certain tokens for that startup in exchange. And if they become successful, obviously their token count, their token price goes up, so you are rewarded in that sense. You could always sell them, you could keep them, hold them, etc. So you, if you compare it to Kickstarter, this is a better model. Plus, the person raising the funds, he does not have to pay a cut like 5 or 10% to the middleman. So that is how DApps will in that scenario. Similarly, you have Uport. So digital identity is going to be a very big thing in coming days. Everyone wants data, right? Everything is on. Everything is going forward. Everything is going to be about data. Okay, so digital identity, everyone wants to protect it. We've seen how Facebook, suffered a lot in the past few months on what happened at Cambridge Analytica. So Uport is one such startup which lets you to create your profile, keep complete control of their identity and personal information. Instead of relying on government institutions and giving their identities to third parties, you can create your identity here, and anyone who wishes to use or do KYC for you, etc., can connect to Uport. You authorize the transaction, they can only see fields that you have authorized, so it is secure in that sense. Next is Block Apps. So Block Apps is like a Play Store. it is providing easy for enterprises to build, manage, and deploy blockchain applications instead of, so like we talked about some time ago, like each of these companies are trying to build their own blockchains with their own tweaks, etc. Block apps, it provides you easy way to build and manage and deploy blockchain applications, right from the start till production systems, integration with your legacy systems, etc. So they have they have designed the interfaces in such a way that even if you're working with very old systems, they would still be able to integrate it using their touch points. Next is provenance. So it is using Ethereum to make supply chains more transparent. We talked about, the trade supply case, right? Trade supply chain. So provenance is built on that use case. By tracing the origin and history of project aims to build an open and accessible framework of information so that you as a customer are always aware on the origin of that particular product. So today when you go to buy a product, even if it is written made in India or made in China or made in US, you don't really know whether the product was made there or the label was made here, right? Because people can always lie. But on provenance, right from the inception till the delivery, at every step the product is tracked, so you could be sure of where the product comes from. The next is Augur. Augur is prediction and forecasting market platform that allows anyone to forecast events and get rewarded for predicting them correctly. So it is like you go on this site, they will ask you who is going to win. Say for example, there's a match today between Mumbai Indians and RCB. They would ask you this question, you vote for Mumbai Indians. So it is relying on the collective intelligence of the network. If say 70 or 80% of people are guessing it to be Mumbai, then there are high chances that it will be Mumbai. So it is relying on the collective intelligence. So it also rewards you for the right kind of prediction and forecasting. So they use that data to come up with predictions and forecasting, and you as users get paid as in certain incentives to take part in it. So these are the major ones. There has been a lot of industry interest in these startups. People are using it for different, they're using for different use cases in their specific organizations. But there are a lot of other DApps also. So this website that I've mentioned, State of the DApps, you can always head there and see other initiatives that are there. And if you feel any one of them are interesting, you could invest in them. You could test them out, whatever you can do. So
Hey Sunil,
yeah.
so why are we calling them as DApps? Why not we are calling them as Ethereum app or blockchain app?
You can call them. You can call them, but that was the name that was given, DApps. So, industry calls them DApps. You want to call them Ethereum apps, you can call them Ethereum apps.
Okay. But is this DApp, if we tell DApp, it will be always made on top of the Ethereum platform, or it can be any platform?
These projects, like I said, Bitcoin blockchain did not have that underlying capability. It would not allow you to create it directly on top of it. So it had to be enhanced to allow this. The enhancement itself is Ethereum. So if you use the Ethereum code, okay, add certain changes to it and call it whatever, like you call it your name chain, okay, on that obviously you can write code apps, and you could call it your name apps. So the platform that currently supports all this is Ethereum. You take Ethereum, build something on top of it, it is available to you, so you can name it anything. The standard or the public implementation that is there currently is Ethereum.
Okay. So Sunil, I have one basic question. So as like Ethereum, suppose I want to develop an app for Ethereum, what does this mean? Already there is worldwide network running on Ethereum and I have to connect with that?
Yes.
Okay.
So all these apps basically they are using those interconnected networks
Yes.
which are built on top of
So
Ethereum only.
Ethereum itself wants to call itself as I mean the supercomputer network. So there has been a lot of criticization also wherein people are linking it to, referring it to as Skynet and those things. I mean, the sci-fi movies, wherein it would be able to control everything, etc. Vitalik sees that as criticism, and he feels it is. I mean, that will never happen. But obviously, I mean, there are different line of thoughts. So because
So
on
in
any of these things in Bitcoin, even in the Bitcoin blockchain or on the Ethereum blockchain, uh, because everyone is connected and working for the same purpose, and the underlying platform controls that, you have enormous amount of processing capacity that is available. So if someone is able to make, somehow control that for a malicious purpose, uh, they could be, they could be able to control anything.
okay. So in simple term, if I understand, Kia, those all interconnected worldwide computers, those are simply a server for me,
So
and
if you
I
talk
have to use
in
it. Yeah.
web terms, yes, those are servers. But in terms of web, a server is responsible, and it is the only party that you as a client would be interacting to. You always know who you are interacting to. The server will always know who you are. In terms of blockchain, there is no dedicated server, so no one is a server. Everyone is a client, and everyone is a server. Whoever is
Yeah,
participating in the network.
agree. That thing I told means that is as like a server on which node it's going. I have not to care about that, but I will
Correct.
get my response back.
Yes.
Okay. So basically, because you told me once, if I want to buy some Bitcoin or something, I have to go on some Coinbase or somewhere else.
Yes, you can
So
go to a lot of these exchanges.
okay. So if I talk about the Bitcoin only or Ethereum, they works only on private or public key. Then why Coinbase was asking my here means give your
So
license ID or other
I
ID.
said this last time also. So when these things started, they were really not asking about any of these. They just wanted your email address and password. Email address so that they could send you communication and these things. There was a lot of government crackdown that happened because these were being used for illegal purposes. Read about Silk Channel. Okay, so Bitcoin was being heavily used for illegal purposes, marijuana trading, buying and selling, uh, the dark market as you call it, so selling of uh, illegal items, selling of guns, etc. So that is why the government wanted to keep track of these things. Uh, Trading also, so a lot of people were laundering their money using these platforms. So they would buy, anonymously buy Bitcoin or Ethereum, send it to a country where they wanted to send the money. The person there would receive it, sell it, and convert it to the local currency. So money laundering had become very easy, and a lot of money laundering did happen. When there were sanctions imposed in Iran, a lot of Iranian nationals or people who wanted to do transactions pushed money into the Bitcoin blockchain, bought Bitcoins, and sold it in other countries where they wanted to send money. So to keep all these money laundering and anti-terrorist financing, these things in place, the governments asked all these exchanges to start capturing uh, personal details. So your passport ID or SSN number or driving license, whatever proof, so you could be linked to that particular account. And this has started happening not long back. So last year there was very heavy push, and there was a lot of so the Bitcoin or even the basic blockchain was based on the principle that you should be anonymous. So people contested the fact that if I have to link these things, I no longer remain anonymous. The government is always able to track me. But most of the governments said either you do it or you close your operations. So people had no other option but to do it.
So Sunil, now we have learned Bitcoin, and as you discussed, anyone can be client of that, means a
Correct.
client or node basically. So
Yes.
assuming I have become a node on my system, so only thing which I need some virtual currency or Bitcoin in my wallet, because
Correct.
I can also create the wallet. So once I'll get that account, I can start transaction.
Correct.
So only to get that Bitcoin in my wallet, I need that driving license and some other things.
Yes, only to get that you need that. In US, it has become a lot more complex even in taxation terms. Whenever you buy it, whenever you sell it, whenever you hold it and you receive gains out of it. So, for example, you have USD, you are holding Bitcoins. You see the price for Ethereum is going to rise in the next hour due to some news or whatever, right? So you convert your Bitcoins to Ethereum, okay? So that when the Ethereum price goes up, you sell those Ethereum and then convert it back to Bitcoin because you want to hold in Bitcoins only. So even this internal change between like using a service like Shapeshift, you converted your Bitcoins to Ethereum. The Ethereum rose in value, and you have to pay taxes on all of these.
Got it.
Yes, all sort of transactions you have to pay the tax to the government. That is
So
why they are
Sunil,
even tracking it, and a lot of people received notices in the US this year for not filing their gains correctly.
Sunil, one question. Means
Yes.
again, we are taking the example of Andhra government for transportation or land selling. They have created blockchain implementation. So what I do, can we assume that will be the permissioned blockchain?
We spoke about this last time also. So yes, not everyone should be able to add transactions there, right?
So
The view should be
okay.
public. Anyone should be able to read it if the government wants it. But to be able to add the records should be in controlled manner.
Okay. So what makes my question? If there will be one node, means where will be that transaction? If okay, let me put my question again. So assuming I want to create a permissioned blockchain in my environment for my own purpose, so where will put my data on my servers or on the global network which I discussed, blockchain-based Ethereum network?
No, you would not
Where
put it
will I
there
put?
because you would not put it there because it is not designed for that purpose. So you make your own blockchain, okay, a private blockchain. It will be put only on that blockchain, and two blockchains will not talk to each other unless it is multi-chain, which is designed specifically for that purpose, wherein you have different small blockchain networks, and you want to connect them to talk to each other. Then you have the multi-chain platform. But because your Andhra government use case, you do not want it to link with a similar initiative, say in China. It makes no sense, right? So your initiative is specific to you. You would hold that information only on your private blockchain.
Okay, so talking about the private blockchain, it means there will be 10, 1500 or 500 computers linked to each other.
Yes.
Am I right?
I mean,
or okay.
Whatever,
So
yeah.
If those are the 500, what about the consensus? Means first thing is that will be governed by some person, official person. Then in this case, isn't it as like a earlier database server?
But that database server is that database server is not available to everyone. No one can verify the audit trail, etc. It is not publicly available. If I make that publicly available, yes, that use case will not make as much sense as it does now. So if I make all the transactions, so every day, whatever transactions are happening on the network, I push a list of it to all the citizens of Andhra or anyone who is interested in doing land registry in Andhra. If they have that information available, might not need the blockchain. But still, it would not make that much sense because every day I would be generating a lot of traffic for everyone to see, which they really might not be interested in. But when I put it on the blockchain, no one is to not everyone is supposed to download it every day, but whenever I want to see who is the original owner for a piece of land X, I just need to follow the block so the address of the person who owns it currently, and just keep following the previous blocks to see the ownership history, right?
Okay.
So it still makes sense in that case.
Okay, so you mean to say that for that case, as like Oracle has also done the similar implementation. Okay, so coming on the question, if I want to make my private blockchain now, which we discussed, so there will be 500 laptop computers I need, and I need to interconnect all those nodes. Am I right?
You really don't need to do it yourself as a government or as a person. You would have everyone in Karnataka or anyone who wants to participate, right, as a node available on that. They would be able to see it. In terms of making transactions, there would be certain so in initiating transactions, it could be fine. You would still make a sale to someone, you transfer the ownership rights to someone, that transaction gets pushed on the network. Now mining that block, okay, or confirming those transactions, that could be restricted to a certain number of nodes pre-identified, okay, in the network. So
Okay.
only when they take the transactions and put it on the block and make it available for everyone to see, only then your transaction becomes complete.
Okay, so on that computers, Ethereum should be the first software which should be installed there.
Depending
Because
whether you want to use the Ethereum platform or you want to use any other platform.
but we need some platform. We are
You
not going to write
obviously all of these computers will need to have a platform and the same platform, because only then they'll be able to
then they
talk
can.
to each other. Yeah.
Okay, got it. Okay, thanks, man.
Yeah, I just want to just highlight few things here, Sunil.
Yeah,
Yeah,
Kaka.
so in terms of his question, his name is, I guess, Sunil, right? Again.
Yeah.
Yes.
Okay, so hi Sunil. So in your question, you're asking many times that if I want to set up a private blockchain, so do I need say 500, 1,000 laptops or computers in my hand or in my say my network? So that is not the case. I mean, you can open your blockchain over the internet, okay, and you can open the membership to attach or the join your blockchain over the internet, and that link can be again password protected, or it can be given to certain people who are authenticated members that someone who subscribes to it. So that can be controlled independently, how to join the nodes and the members in the blockchain. So that doesn't mean that you always need a private network or private internet in your hand. You can have it if you're affordable to it, but you can still open the gates over the internet, and you can let the subscribers join your blockchain to help out in the mining and the transactions that are happening in the blockchain.
So what do you mean, Kaka? Means 10% can make their own group inside that global network which we discussed.
Yeah, I mean, in the global network, I mean to say over the internet, you can open your blockchain membership. Okay.
No,
That
Kaka.
would,
So his question was basically Andhra government has come up with a land registry application.
okay.
Okay. So he was talking about that specific case, whether it needs to be
Okay.
really on the public Ethereum platform that we have currently, on which the ethers are produced.
Yeah, that is not required. I mean, the
Yeah.
Ethereum source code is available for free.
Correct. So you
But
can
government
download that
also,
code and
yeah,
build your app on top of it,
exactly.
and only people who are required to use it, you can have them on the network.
Yeah. I mean, you can always protect your blockchain network by keeping it behind a firewall or other, network security aspects that are applicable for, joining the network. And I mean, as your case is, you want to, transact a specific entity, not a coin in this case. Okay, so you have to design. I mean, you have to customize the Ethereum source code to, transact the records, not the currency actually. So on the public Ethereum network, what we are transacting is the currency. But in your case, it would be a land record, so that will be definitely some PDF file, I guess. So that PDF data becomes a currency in that case, not the actual, the currency.
Okay.
Yeah.
Okay, and still one last question, sorry. So we discussed double spending last time. That was the
Yes.
major issue. Now coming in term of Ethereum platform, we told that our smart contract will be automatically executed as
Correct.
like triggers in database.
Yes.
On some condition will happen, then it will be. So as
Yes.
like in betting system, I'm going and I'm saying if India will win from Pakistan on this date, this amount of money we are putting on bet.
Correct.
Okay. So the same thing I can do with you, Kaka, Karachi, and everyone. Basically, 5% are there, so I can put $100 for everyone, 500. Although in my account there is no 100. Then what will happen at that time basically? Because in my account there is only 200.
Hmm.
In that condition, as met India had lost, so I lost my money. But I have only 200. I have put 5 bet.
Didn't really get it. So
Okay.
if you are betting currently, you have to pay the
Mm-hmm.
bet right at the start.
So at the same time, I have to pay.
Correct. I mean
So,
that is the normal how you would bet, right?
Uh, uh, Guys, so what I have in the next set of slides is I have a good example to get you all understand how actually smart contracts work. Whenever a song is streamed, some amount of currency or money is deposited into the artist account. Okay, so that is basically logic inside your smart contract. So that is one type of smart contract, I would say, for streaming music. Okay, so this is customized for music. So when I explain that contract to you guys, we'll come to know that how contracts are designed, and basically how they can be customized for each and every use case, like for music, for land records, or any other entity that you want to manage over the blockchain.
okay.
Okay, so we've got only few slides which we will cover quickly, and then we can start with the tech detail. So, like DApps, there was something also called as DAO, which is decentralized autonomous organization. Sometimes also called as DAC, which is decentralized autonomous corporation. It is an organization that is in run through rules encoded as computer program called smart contract. So all the bylaws, etc., that apply to a company are not automatically, are software programmatically created as a smart contract and is deployed. The concept here is that because okay, Sunil or whoever is not on mute, can you go on mute? We're getting a lot of noise. Okay, thanks. So basically you would have a company which no one owns, okay, and anyone who is participating or who has purchased tokens for that particular DAO becomes an owner. There are contracts that are coded, so no one can modify them, no one can roll them back. Okay, so for crowdfunding or for any of these things you could use DAO. So there was a company, there was an initiative called the DAO, the one of the implementations of DAO, and they raised up to $150 million, I guess, last year. We'll talk about in the next slide. For now, so basically they are smart contracts and they amount to a series of bylaws and other founding documents that determine how its constituency, how much stake one owns, and anyone around the world who has bought the DAO tokens with ethers will vote on the decision. So for example, tomorrow, the company stock price has risen tremendously. You want to either offer bonus, you want to offer dividends, or you want to offer stock split, etc. So currently, all of these investors are called and they are asked to cast their vote. So all of that could be coded in a smart contract. People could vote, allocate resources, etc., and get returns etc. based on this. Now, currently, all of this happens using the stock exchange, the network, and there are a lot of people involved in doing this. With the DAO, they are saying you would have no middlemen. It would be coded in the smart contract and it would automatically get executed. This initiative was heavily backed by Vitalik. A lot of Ethereum, developers were onto it. It was a very successful initiative wherein they raised 150 million, but there was a bug in the code. Okay, and exploiting that bug, one particular attacker was able to transfer all of that 150 million that was raised to their account. Now people could see that a transaction was happening which was draining this particular DAO's account and taking the ethers away. Like in banking system, you could not shut down the Ethereum server on for DAO. So you could see that a fraud was happening, but there was nothing that could be done. And within a matter of some time, all of the money was gone. So when the bug was found, fix had to be put, but the money had gone. Okay, and like we say that a transaction is irreversible, immutable, etc. in blockchain. Okay, so everything had gone. Now a lot of people had lost their money. Okay, they had lost ethers, which were valued highly. So as a fix, it was decided that we would do a hard fork on the DAO, the blockchain that was supporting it. Hard fork is basically when you decide to create a branch out of the current network. So these guys decided we will go back in the time to the block wherein the original people had their money. From there, we would create a branch out. So these people would still have their money in their accounts and the attacker would basically be left with nothing. While a lot of people were happy with this because they would receive their money back, a lot of people were also not happy with it because this went against the principles of blockchain. We were reversing transactions, we were reversing the state of the system, and they thought it would be a dangerous precedent to do this, because then in the future also you cannot be sure of your transaction, that you do a transaction today and tomorrow a group of people decide that we will be rollbacking the system to XYZ date, and what happens to your transaction then. So there was a lot of debate that happened, but ultimately for the greater good, they hard forked it. Okay, and from then obviously there have been different school of thoughts wherein certain people think that it cannot work in the current way. The system cannot be trusted because it has been hard forked once. Ultimately it went through. Now there are two Ethereum main nets, you can call them. So the first one is called as Ethereum Classic, on which the hard fork happened, and the other one is the current Ethereum blockchain on which we do all the transactions. So all of the transactions that happened previously to the hard fork are available on both the nets, and whatever the transaction, the fraud that happened on the main net remains on it, and people have moved on. So people did get their money back, but this became a major talking point in blockchain circles, wherein people started talks about whether we are ready with the technology, whether we should really get onto this when these kind of things can happen. So yeah, so this is what I was talking about when I said initially that though I keep saying it is immutable, it is irreversible, but there has been a case that transactions were really rolled back. But obviously this was done with consensus of a lot of people, and because it was realized that there was a fraud due to a bug, and it made sense to do it. So that is why it was done. Ethereum mining is same as almost the same steps as you do for Bitcoin blockchain mining. So go to Google, search for GETH, gets. Earlier there used to be scripts. It used to be command prompt based. Now you have exe for Windows. If you want to do it for Linux and Mac also, you've got scripts available. You just go download it and run it. It will, if you're downloading the exe, you would get the exe, double click it, run it, it will install. Like Bitcoin, here also when it installs, it will try to sync up with the network. So if you're doing it in the script version, you would have to follow all this. If you are doing with the exe, we would directly come to, I think, step 5. So up until step 5, everything would be done. In fact, even 6. So that is how you would have the platform available. Then for you to start mining, you would have to install the miner. Like we saw in Bitcoin also, I had installed the platform and then you had to install the BTC miner. Similarly, for this one, you have something called as ETH miner. Okay, so you could go on GitHub and this is also now become available as an exe. You could download it and run it, but obviously you can only do this once you have synced the entire network. So if I show you on my machine, I have Geth here. If I run it, it is obviously not synced, so it will, in some time, it will first do all the verification as to how much I have downloaded, and then it will tell you. Okay, a good point would also be to show you the task.
Could you increase the font size?
Okay, still not visible.
No, basically font size.
Okay, I don't see option to increase it here. I will have to close and maybe open it. Anyways, the purpose was to show you. So if you keep seeing Geth, when it starts downloading the transactions, you will see my CPU usage going beyond 60% or so. So while it is still, I mean, it is very resource intensive. So if you really want to do it on your system, I mean, decide whether you want to spend that kind of processing capacity, etc. But you could still do it on your home computer, is what I'm trying to show here. So it is still not started. Once it has synced, it will start and it shows you something like this. So we're doing it before the start of the session. In some time it will start syncing, so we will see on the screen also. So it will keep importing the new block headers and receipts. Not yet started. Okay, so when this is happening, you will see that the CPU utilization would be much higher. It would be 60 to 80%.
Could you give the command which you are using here?
I have not used any command. This is like a normal Windows application. So in the PPT, obviously there are commands written. Okay, that used to be the earlier, method. But now they have made it like any other Windows software that you get. So you get an installable, you double click it, and it automatically starts. Like here also, I just double clicked on this Geth, and it started. If you were doing it earlier, you would have to go to the command prompt and type getH, and then it would start. So I've written the steps here, but you don't need it anymore because it is available as an executable now. Okay, we'll come back to this in a few minutes when it starts. So these are the steps. Okay. So mining follows the same principles. Currently, it follows the same algorithms also. It follows the same proof of work algorithm. But like I said in the start, they want to get away with it because it is using a lot of electricity and processing power, and they want to simplify it. So currently it uses something called as a Dagger Hashimoto algorithm. You can read about it, but you don't really need to know about it. Okay. So what they're saying is in the coming times, they will replace this proof of work with proof of stake. Now we all know what is proof of stake. Proof of stake is there are people who will own stakes. When I say stakes, that many number of coins in the platform, and whenever a new transaction is up for mining a block, depending on how much stake you have, you would get priority to mine that block. So you are earning incentive for mining a block depending upon how much stake you own in that particular network. Now it might seem a little weird currently, but thing is, in proof of work we have kept all that complexity etc to make sure there is no bad element in the network, so everyone is working in the best interest of the network. That is why we had kept it so complex, that if a person is spending that much effort, uh, he would be doing it for the right cause. Similarly, if a person had to do something wrong, he would have to have control of at least 51% of the network, right? In proof of stake, if a person is buying that many coins of that particular implementation, that means he is already staking his money. So for example, I make an investment of say 500k to get say 100k Ethereum coins. My 100k is already in the network. So if I try to do something wrong on the network, if I try to do a fraud, okay, my 100k will be forfeited and will be used to recover the fraud or losses that my fraudulent transactions would have made. So I would not do it, because I always know that there is a deposit that I have paid to the network to mine this transaction, right? So that is proof of stake. Proof of stake is not something that has been suggested now or people have come up with now. It is being talked about from 2011. There have been other coins. Obviously they did not pick up, but there have been other coins who ran with this concept. So unlike proof of work, where algorithm miners rewards miners who solve mathematical problems, here the goal is, with proof of stake, the creator of a new block is chosen in a deterministic way. So you all currently, the wastage of electricity or processing power, a lot of it happens on the Bitcoin blockchain, because no one knows who is the right miner, right? So everyone mines it in the hope that if they solve it, they would get the uh, reward for it. But here we know in a deterministic way that if this person owns say 20% of the coins, then 20% of the transactions will come to him. So we decide it based on the ownership right away. So others don't have to mine, because they would never get it to mine. No block reward. So like there we have block reward. Here we don't. In the Bitcoin blockchain, here all digital currencies that are previously created in the beginning, and their number never changes. This means in the POS system there is no block reward. So the miners will take the transaction fees, and that is why we are introducing a new term in the proof of stake. Miners are referred to as forgers, because they just forge the transaction or the block. They are not actually mining it. So why does Ethereum want to go to proof of stake instead of the current proof of work? Like we talked about, miners waste a lot of energy in the proof of work because everyone is competing for creating the next block to get the reward. Based on a data from 2015, one Bitcoin transaction requires the same amount of electricity as powering 1.57 American households for one day. So to mine one block, you would be spending that much electricity, and which has obviously gone a lot up in 2017. Correct. So Vitalik and some other experts, they felt that this is not correct, and by 2020 Bitcoin transactions may consume as much electricity as Denmark. So this is a worrying problem from the environment perspective and from the cost perspective also. So that is why they wanted to have a mechanism that instead of proof of work, you have some other algorithm to reach at the consensus, but at the same time have the same level of security that this offers. So that is where proof of stake comes in. So what happens to miners? Currently, everyone is able to join the network and do mining and try their luck. So if they get lucky, they are able to solve a block, they get rewarded. But in proof of stake, what happens? Because it is decided. So if you read the statement written at the bottom half, given by Vitalik in one of the Reddit sessions, he says you don't have to do anything. Like currently you are a miner, you will automatically get inducted after some point of time, and there is no priority scheme for anyone to get inducted into the validator pool. So validator pool is basically the people who would be owning these uh, proof of stakes, and you you have whatever ethers you are holding, whatever share that forms of the network. So for example, you are holding 100 say ethers and the entire network has say 1 million. So whatever ratio it comes to you, you would still get that much fees for mining and that much transactions for mining. So the algorithm that he has come up with is called as Casper. That is the new proof of stake consensus protocol, and it will be implemented. There will be an existing validator pool which will be pre-decided. If you want, you can go ahead and join the pool whenever this happens. So miners will obviously can still continue to mine once that is implemented. So it is not that the network is pre-deciding it themselves or they themselves are becoming the miners. You could still join it, albeit you would have to have coins or have stakes, so that if you try to do something wrong or do some fraud, it can be recovered. So obviously people raised questions. Will it be as safe as you have in proof of work, because we are reducing the complexity? So using proof of work system, bad actors are cut out because of the economic and technological disincentives, because you'd be spending a lot of effort doing that. Like we've seen, proof of work is very expensive. You have to own at least 51% of the network. Similarly, even in proof of stake, to be able to do that kind of fraud or to control that kind of network, you would have to spend that much amount of money. So you would always be risking a lot of money if you want to do some fraud. So economic finality is accomplished in Casper by requiring validators to submit deposits to participate and taking away their deposits if the protocol determines that they acted in some way that violates some of the rules. So that is called as slashing. So it refers to circumstances wherein user broke some law that was not allowed as per the algorithm. So that is why it will still be safe. This was the theory part of it. Now from the next slide, Kaka will take you through solidity and other details. So Kaka, over to you. Ashok, can you make Kaka the presenter now? Ashok? Guys, are you able to hear me? Others?
Yes, Sunil, I can hear you.
Okay, it seems Ashok is away. I don't know whether I can make you the presenter. Let me try.
Yeah,
Okay,
can you
you are the
guys see my screen?
Yes, I can.
Yes, we can see.
All right, guys. So now you have learned about all the theory and everything. I mean the background of Ethereum and the platform. So now let's jump on to how practically it works. And if I want to make something working on Ethereum platform, how to make it. So basically, to create anything or to deploy anything on the Ethereum platform, you need to program in the language called as Solidity. So Solidity is a language developed by Ethereum team itself, they themselves also use the same language to they run the currency on the Ethereum platform. So so what it actually controls is basically a contract oriented and statically typed programming language used for writing the smart contracts. So we'll see how what exactly the smart contract is. So when we write something on in the Solidity language where it runs, so it runs in a VM called as Ethereum Virtual VM, sorry, Ethereum Virtual Machine. So this is basically a node that everyone on the network is hosting. So when I say that I'm part of Ethereum network or Ethereum platform and I'm contributing in the Ethereum platform, that means I'm hosting some nodes which are like small virtual machines and they are running Ethereum on it. Okay. So this language Solidity is basically ECMAScript standard, and the syntax is very much similar to JavaScript and C. The full documentation can be found at the official site solidity.readthedocs.io. Now let's jump on to the smart contract. So what actually the smart contract is? So now my platform is ready. Ethereum is providing me a blockchain. So on top of that blockchain, I want to run some entity. For example, I want to create a new currency on top of Ethereum. So what Ethereum does is it allows you to create your sub currency called as tokens in this case. So a token is basically running on Ethereum itself, but internally it is transacting ethers, not the actual, not your new currency. So internally it works on Ether only, but your token is something that you can name as per your choice. You can name it on on your name. You can give it a specific symbol to it, and you can run it on the Ethereum platform. So smart contract basically contains all the business logic of your entity. So suppose I'm creating a currency called as KYX. So in that KYX currency, suppose whenever some transaction happens, and I want to make some difference, I want to make some different logic before a transaction is completed. Suppose, just in case the example that Sunil mentioned. So whenever music is streamed, okay, so that means something is transacting on the network. So in that case, I want to deposit some amount of the cost to the artist account. So that particular custom logic you can write in the contract. So contract basically encapsulates all the behavior and the characteristics of your object that is going to be transacted over the network. In the networking terms, we can call it as a protocol. For example, suppose we have different networking protocols like HTTP, FTP, SMTP, and others. So each and every protocol has some different signature, some different behavior, and all the different handlings that are needed for that particular protocol. So if I want to connect to HTTP server, I definitely need an HTTP client for that. So in similar cases, if I want to handle my new currency, I need a contract of that currency. Got it, guys?
Yes, we are listening, you, Kaka.
Okay, sure. So for each and every operation that is getting performed on the entity has to be precisely defined in your contract. Okay. So now let's come to the actual implementation in the language itself. So we are saying that smart contract contains all my logic and everything, the operations on the entity. But what smart contract is in your language perspective? So in the language, classes. So contract is very similar to the class. I mean, when I'm going to show you the actual code, you'll come to know it is very similar to the class. So a smart contract is having below contains in that. First and the very important is a constructor. So whenever any object is created, I mean, of your whenever you're deploying your contract on the network, so the constructor is called with the parameters if it is having. Otherwise, it will be called simply and create the instance of your contract. And post that, everything would be handled on that particular object when it is transacting over your network. So, uh, so the other things that contract is having are state variables. State variables are the variables or the properties which are attached to the smart contract. For example, suppose I'm for a particular song, suppose a song is getting played. So in that case, I need to know what is the address of the artist of that particular song. So that should be attached to that particular contract. Then we have functions to make operations on the contract or the entity. Smart contract then supports inheritance and polymorphism like any other languages that we know. So over the network, where is my smart contract in the blockchain? So the cube that I'm showing here on the screen is a block on the blockchain. So basically, a block it contains the data. I mean the actual entity data that you are storing. For cases of currencies, it is nothing but the ledger. And after that, there are two important parts of the block. One is the hash of the current block. This hash is basically unique for your current block because your current block would be having some particular transaction data onto it, and the hash would be again a unique for that. And there is another one which is again a hash, but it is the hash of my previous block. So that means if you visualize a picture of linked list in the programming, so in the linked list, what we have is we have one value and we have a pointer to the previous value. So similarly in the blockchain, it works in the same way. So whenever any block in the middle gets changed or gets tampered, the hash is not valid for that particular block because the data is because the hash of the current block is the signature of your data. So if you're changing the data, the hash would be changed and the same hash should be there copied in the previous block. So that chain will be broken. So that is how it is maintained. So now, where is my contract on this block? So my contract is basically in the data part of this block. So the data is basically managed by my contract. All the operations, all the transactions happening on my data would be managed by my smart contract. Okay, so now let's jump on to Solidity language uh, resources or the reference of the language. Okay, so when you want to code into Solidity, you should know what actually the language contains. So language are different types, like it has var, string, uh, uint, that is called as unsigned integer. Then we have Boolean, byte. So these are the primitive data types in the Solidity. Then we have some types called as the range. So the range is the range types. Basically, in Solidity or in the blockchain, that just now Sunil mentioned that the current implementation is utilizing a lot of electricity, and that is not acceptable because electricity is something that causing damages to environment. So in Solidity, we have very precise types to work or handle every piece of data. For example, suppose you have a say a name of the song which you want to limit in some particular string length. So in that case, you won't be specifying the long or the data storage that is utilized on each and every particular block is directly proportional to the electricity and everything that is getting utilized for mining that particular block after this. So to use the data types precisely, we have this range types. So for integer, you can create an integer of 8-bit to 256 bits based on your requirements. Similarly for unsigned bits, and then again for the bytes. Control structure is again almost very similar to the JavaScript. We have if, else, while, for, and break, continue, and all the other control structures that are there in the JavaScript. Then we have arrays. We have both variably and fixed size arrays here. We have structs. which is for defining a small data types which are complex in the nature. And then we have enums for specifying the user-defined types. So what are special things in Solidity apart from the basic features that JavaScript or any other language that provides? So in Solidity, you have a special type called as address. So address is nothing but a 160-bit value, which is actually a unique for each and every node that I would say, or each and every actor in the network. So whenever I'm saying that I want to send a few amount of currency to the receiver, so every basically actor in the network should have an address, and for that we have a special type called as address. So this is an alphanumeric value which does not support any arithmetic operations on it. It's unique, and so that's why we have special type to handle it called as address. Then we have mapping. Mapping is a key value storage just to create small dictionaries and utilize them as storing values with specific keys. Then we have globals. In the globals, we have TX. TX is for the transaction. So whenever any block is or whenever any transaction is happening on the network, so transaction related data is stored and available in the contract in a global variable called as TX. Then we have MSG. MSG is basically a message that originates from the sender to the receiver or the initiator of the transaction to the to the contract. So these two are available anywhere in the contract. Again, there is one more called as block. So block is basically a pointer to your current block that is getting processed. Then we have ether currency units that Sunil also mentioned. We have, you can say that one ether instead of writing some complex number for that. Writing ether makes Solidity understand that you are mentioning ether. Similarly for V, Sasbo, and Philly. Then we have time units, which are very naturally written like seconds, minutes, hours, days, weeks, and years. Then we have some special hashing functions like SHA3, SHA256. These are basic, standard hashing functions. They take bytes and returns the bytes 32 bytes data. Then we have something called as functions on addresses. Like I mentioned, first type as address. So you have a 160-bit address. Suppose you want to check the balance of that address. So you just have to say that address as a function and just pass the address and say dot balance. You will get to know the exact balance of that particular address. So the wallet balance. Similarly, we have a call function over the address. You can call a specific function on that address. So I'll explain all these things in detail directly into the editor. Then we have function modifiers. So function modifiers are basically, so whenever any function is called, suppose I want to attach some specific condition on that function before the actual function body executes. So that is called, the way to define it is the function modifier. Then we have events. Events are basically for logging and debugging purposes. We'll also come to know that in the demo. Then we have libraries also in Solidity. Basically, it provides the concept of libraries to create, the reusable code that can be called from different contracts. Suppose there is a utility function that I want to declare, and instead of rewriting that small function at every place, I can just use that from the library. So I have put all the sample code on the Git repo. So you can also, you can check out that Git repo, or you can download from direct link. And yeah, so the screenshot that I'm showing here right now is a simple coin contract. So I would not just show you the screenshot, but I'll also get you all into the editor and see how actually it gets coded. Okay. All right. So, is my screen visible to you guys, and is the font size fine, or should I increase it?
I think it's fine.
I'm good.
Fine.
Yes.
Okay. All right. So, the example that Sunil mentioned. So, whenever a strong is streamed, there has to be some logic behind that. That some royalty has to be, credited to the artist account. So to, implement that example only, I created this contract called as music coin. Okay. The minter is basically the creator of this coin. Artist is the artist for a particular song, and I'm declaring a royalty amount that is 5 in this case. So you can see this is a special type in Solidity address. All right. Okay. Then I'm creating a mapping, basically a dictionary of say balances, and this mapping is basically address to the unsigned integer. That means when I want to check the balance of particular address, I'll just have to call balances and pass the address, and I'll get the unsigned integer. That means the balance of the uh, account. So suppose I have 5 ethers in my account, I'll get 5 as a result when I call it. Okay. So then there comes a constructor. So this is a public constructor. Uh, it just assigns the mentor to an MSG again. So MSG is a global variable. So if I go to MSG and see what are options that are available to it. So first is the data. Data is basically a complete call data that is coming to the transaction. Then there is a gas. Gas is something that a fee which is getting paid for performing this transaction. As Sunil has given you complete idea about it. Then the sender. Sender is basically again the address of the sender. Then the signature is basically the first 4 bytes of the call. That is, so whenever a call comes to your contract, the message is the object that contains all the data about that particular call. So signature is basically the first 4 bytes of that call, and it is again like binary that if we want to persist it and process it, you can just access it from SIG. Then the value. Value is something that the number of V that is sent to me, okay, to this particular contract. So that means suppose I'm sending uh, say 5 ethers or 5 music coins to someone else. Okay, so the value would be coming here. Okay, then this is main function. It simply basically submits the amount given to the owner. So owner in this case, so in the main function, I'll be passing the address of the owner to whom I want to credit the amount, and amount is passed in the next parameter, that is unsigned integer. And again, I'm just checking here that if message.sender is not minter. So minter in this case, I have created something that I should be only be the minter of this particular coin. So the sender itself should be the minter. So this minter I can go here and assign some specific address value, a constant value, which will remain with this particular contract uh, for complete life. I mean, it cannot be changed throughout the whole life of this contract. Okay. Then when I want to send some amount to the receiver, so what I will do is I'll pass the address of the receiver and the amount. Okay. So now here comes my logic. Okay, so you can design this logic as per your customization. You can do anything inside that. That is up to you. I mean, you can just simply say that, don't cut the balances and pass it. That is your contract. That is not the actual Ether currency. All right, guys. So now, when I'm coming in the send function, I'm just checking the balance of sender. Okay. If that balance is less than amount plus the royalty that he needs to pay to the artist, then simply return it. I mean, don't process this send message. simply say that I mean it cannot be processed. Just saying return to it. Okay. Otherwise, just check the balance. I mean, just reduce the balance of the sender by amount plus royalty. So suppose I'm sending $10 for a particular song. Okay, so 10 plus 5, sorry, if I want to, the price of the song would be $15. Okay, so when it comes to this, it would be royalty plus the 15, it becomes 20 for me. Okay, and then, so this amount will be reduced from the balance of the sender. Then I'm crediting the royalty to the account of artist. So when I say balances of anything, so balances of address means the account of that particular person or the particular actor in my network. So in this case, it is artist. So for particular song, I can give the address of the actual artist who is who is the creator of the song, and then in the receiver, I'm just crediting the amount. Okay, and this is a query balance function. Simply, I'm calling this function by passing an address, and it is simply giving me back the balance of the address. So, have you guys understood? Not completely, I would say, but some part of it and some pseudo logic of the code.
So, Kaka, could you repeat what does this address mean actually?
Okay, so this address is basically a unique address. Okay, it's a, unique number basically, I would say, over the network. Okay, so whenever you create a wallet on the network, so that address, your wallet address is the address here.
Okay, you mean my wallet address will be the address?
Exactly, yeah. So when you want to send some currency to some coins to the receiver, so you will have to pass the address of the receiver here and the amount in the number.
So is
Then
it
what
like
is the
public?
public key? Sorry.
Exactly the same
Sorry?
thing. Oh, sorry.
Because this has
Earlier
to
it
be
was
called.
sorry.
Sorry.
Please go ahead. Please go ahead.
Yeah. So because this has to be called by the actual transaction initiator, which is which will be again an account of the same on the same network who is having the same currency on it. Okay. So he should be able to call me. That's why it is kept as public.
No, that's not public. Public key, we want to understand the difference between, because as Sunil described, we can be public key based on anyone
No.
can send money to that public key.
No. This public key is different, and this is declaring a function as a public is different.
No,
No, no.
Kaka, not this related to this Solidity language. I am discussing about the public, private and public key. Public key versus address. Because before this, public key was only getting used to send money. I mean, receive money.
Exactly. Yeah. Yeah. So in the language terms, we call it as address. That's what I'm saying.
You mean
Over
by
the
public
network.
key will be the address?
So public key is
Well,
for the encryption, but your wallet address is different in that case.
okay.
Okay. So this is a simple coin that I have made just to get you understand about how to write a contract. So now my contract is complete. I wouldn't say that this is complete because it should have a lot of things in it. But just to make you understand with a small piece of code, I've kept it very small in size. Okay. Just to let you know the basics of the language. Okay. So first of all, whenever you're writing a Solidity, the extension for a Solidity file is SOL, and whenever you're starting your Solidity code, you have to write the version number with the Pragma Solidity and the version number. So, as Sunil mentioned that this platform is very rapidly evolving. And in terms of the Solidity language, it is also the same way. The new version comes every 7 days or 15 days. So language, definition is also rapidly changing. Some of the code which is which was there. Like for example, I had mentioned var something somewhere in the slide. So var is now deprecated. So these are the changes that are happening in the language also. So you need to be specific with the version number that you are writing, and reference can be again taken from their official documentation site. So just go to documentation site, check the latest version, and based on that you can write the code. And again, I have actually also shared this link of Visual Studio editor, Visual Studio code editor, with the particular extension to install on it. And so if you have that extension on it, for the extension is Solidity itself. And this guy Gion Blanco actually has done a good work for this editor, that so whenever any new version comes up, he updates the language specification, and based on that, it gives all the warnings and errors right when you're writing the code here in the editor itself. So for example, suppose I say var, so it will highlight that var is deprecated one, and again the assignment has, because of that the assignment is not valid. Okay, so the support for the language is also good because it is uh, on the Ethereum network, and Ethereum network itself has a good support to run it, because this whole thing is run by communities and like people like you and me over the internet. There is no one who is actually owning it. It is just the internet. Okay, so now let's jump on to the specials in Solidity. We learned the basic things like what actually contract contains and the few things about the language. So now let's jump on to the global variables in detail. Okay, so MSG is my global variable, which basically represent the current message received by the contracts during the execution. Using msg.sender, you can access the address of the sender. So MSG has all these properties in that, as I had already shown to you guys. Then there is a TX. TX has it basically represents the current transaction in the smart contract and address of the sender of the transaction. So this origin means the address of the the sender. So you will say that why message and transaction are different. Okay, so because a transaction, a message is something basically it is delivered whenever a transaction begins. But okay, but on each, and as this computing is not a server computing, there is no single server who is running this code, and there is no single machine who is actually making it. Okay, so message is something that comes from comes from the sender whenever a transaction is initiated. Okay, but the transaction is something that whenever a transaction begins on some particular node on the network. Okay, so in distributed computing, you have one activity to do. Okay, but that is actually being done by many others on the network. Okay, so for my particular transaction, I need some pointer to it. So that's why this TX is different from the MSG. And then again, TX has origin, which is again the address of the sender of the transaction. For example, to explain this in detail, uh, that would be coming in tomorrow's lecture, I guess, when we will discuss about mining in detail. Uh, I'll add a slide for that. So what happens when you are mining for some? Um, so what happens when you're mining on behalf of someone? Okay, so there are miners on the internet, which are like big miners, I would say. And what they provide is you can take transactions from them and you can mine for them. Okay, so you are a sub miner behind the main miner that is on the network. So You take a transaction from your provider, you solve that transaction, you solve the block, and you again submit that block to the actual miner who is actually mining on the main network, and you are behind that. You are taking transactions, you are taking work from him, and you are doing work and submitting to him. So in those cases, these are the things which are required when you're working or dealing with your contracts. So gas price is again the gas price that is assigned to your particularly for your operation given to you. Then to simply access the timestamp, we have now as the global variable. Then next global variable is the block. So block, as I said, so whenever you are transacting or whenever you are computing a block, so there has to be some pointer to my block properties. For example, the block dot number. As I said, in the blockchain, you have chain of blocks. So what number block you are actually solving is the number that you get from here. Then there is something called as difficulty. Okay, so this is a difficulty level that is currently there on the block, which is again given in number. So this number has grown up too much right now for Bitcoin, and that's why Bitcoin mining is very costly. Then there are some functions. First one is the block hash. As I said, you always have to calculate and validate the hash of your block. So that's how you can calculate it. And then there is gas limit assigned to particular block. Suppose this, this is again an assignment done from the transaction initiator. So suppose a block actually needs some amount of gas to resolve it or to mine it. So you can check what is the gas limit, and based on that you can decide like if you want to actually mine it or not. Then there is Coinbase. Coinbase basically returns the miner's address who is actually mining it. All right. So we have some arithmetical and cryptographic functions as well in Solidity. One of them is simply assert. You can simply pass the condition in that, and if that condition fails, it throws an exception, and if it doesn't, then it simply returns a boolean to you. Then you have add mod function. Add mod is basically simply shorthand for addition of two variables and then modding with the third one. Similarly, we have mul mod, just multiplying two variables and modding with the third one. Then you have some hashing functions like this one, kickass 256. Then you have SHA3, you have SHA256. These are again based on your requirements. If you want to, for example, in terms of so Sunil, right? So you mentioned a use case where you need to handle land records for the government. Okay, so in that case, a land record data, okay, it cannot be placed like a plain text on the block. You have to calculate a hash for that particular data and secure it, because it should not be visible directly whoever becomes part of the network, but it should be visible to your code, but not the actual miner who is actually mining it. So to protect all these things, we have some hashing functions. This can again be used for any kind of utility. If you want to simply get a signature of some data, you can use this function. Again, this is again different kind of hash function. And then we have address related functions. As I mentioned, address functions. So when you have an address with you, you can simply get a balance of that address by calling the balance. Then you can simply send some amount of currency or coins to it by simply calling the send function. And then you have again the transfer function. So these are like functions available to you. It is up to you like how you implement your logic in your contract and how you utilize all these functions for it. So the difference between send and transfer is that I mean, it returns false when the transaction is failed, your operation is not successful. But so this one returns false a Boolean result to you. But transfer is something that is transactional, and to handle or to catch the exception, this actually throws the exception, and you will be able to revert your transaction or revert the state of your contract based on the transfer function. Then there are something related to specifically to contract itself. So this that this what this is, I mean this in programming language is always pointing to the current object. So similarly here it points to the current contract. Then there is a revert function which is for transactions. Suppose something happens, some error comes up, and you want to revert the state of your contract, you can simply call the revert function. Then again we have a self-destruct function. This is very important, and something like shift delete here in a computer. So if you want to destroy the current contract completely, so you can call this, but it's very risky to use this kind of function if you want to implement safe contract, I would say.
So just one
Alright.
question on this
Yeah.
delete function. It will just block any further transaction, but whatever transaction, whatever contract has been executed earlier, it will keep it, right?
Yeah, it will keep the. I mean, there is no way to modify the previous one. It is just for your current transaction. I mean, the current contract, I would say.
Yeah. So the earlier example which Sunil was mentioning about that rent thing, that due to certain things the rent will be automatically executed. But now with this function, I've seen that position can be also violated, right? In the future, if somebody have this piece of execution, then probably it will stop it, right?
No. This is something like a condition. For example, suppose in this case, in the song case, okay, I create a function to basically suppose to change the ownership of the or to change the copyright of the song. Okay, and in this case, suppose I realize that so changing a copyright or the artist name or the artist address is something very dangerous for the song. Okay, because if I change the address itself of the song, I mean the artist, I mean it may go into any other's account, the royalty amount. Okay, so such kind of things, when you detect that something is very poisonous and very hacking attack, in that case you completely call self-destruct. So that means that nothing is available. I mean that whole contract transaction is not available to you. I mean you tried something to hack, and I don't want to give you explanation about it. Got my point? I will simply destruct myself. I'll say I'm not going to do it, and I'll simply return your funds to the given address. I mean, you
Okay.
send me some funds, but you call some specific function to change the the address of the artist. Okay, that's one kind of example. When you detect something poisonous for the blockchain, you can simply say self-destruct.
One more question. Are these contracts are like time based or time bound? The reason I'm asking is, suppose you want to pay the royalty, but the royalty you want to pay for the first 5 years only. After that, it become free.
Exactly.
Can you
Yeah,
make?
I mean
So
you can create
all,
the
all that
logic.
is logic. Yeah, all that is logic.
Yes,
So anything that you can
yeah.
do in any other programming language, you can do it here. So
Do it
how
here.
to
Okay.
build the logic specifically for your application will depend on the requirements that you have.
Yeah.
Okay.
I mean,
Got.
here you can get the current timestamp, and you can store the birth of the song, some variable, and if 5 years are gone, then you can simply say don't add a royalty and simply do the other transactions here. Okay.
Yeah, Kaka, I have one question related to this gas limit. Means simply we are saying, okay, this is my contract, execute, and we are passing gas limit as 100,000 assume. So what does this mean? My code will be pre-calculated that this is the gas which is required for this contract, or whenever that limit will meet, my code will be stopped.
No, this is something that Ethereum network actually takes care of. I mean, you cannot do anything. You can check this value in a variable and say you can print it, but this is particularly taken care by Ethereum platform itself. So this gas thing is all handled by Ethereum network. I mean, we are not having you cannot change the gas price in the transaction, and you cannot do cheap mining, I would say. Or
No. My question is assuming 1,000 as a gas limit I have set. So now condition has met.
No. This is something that that's what I'm saying. This is not useful to us. This is useful to the platform itself. I mean, whenever transaction is initiated, the gas limit is assigned to it. If you want to check, I mean, what is the gas limit, but you cannot modify this value. You cannot do anything to this value. This is only useful for the actual platform, the Ethereum platform. Okay, but they are just exposed to the language, because sometimes if you want to check what is the gas limit given to this block, I mean, you can just simply check it. Just a read only value, nothing to worry about it.
Okay. And Kaka, when can we? Sorry, please go ahead.
Yeah, I was going with the next set of things. Yeah. Okay, so next is units. So as Sunil also mentioned, we have Ether as a unit, we have V as a unit, we have Pennies as well as a unit to measure the currency values. For example, suppose 2 Ether equal to 2000 pennies, so this would return me a true, because this is a correct condition here. Similarly, for times, you can simply use also use these as a unit. You can see language is detecting as a unit and not giving you an error here. But if I sorry, so these are the units provided by language. If tomorrow some new unit comes up, or if you want to create your own unit for your currency, that is something that we have to implement it customize as a custom unit itself. But the all the calculations would be also up to you, how you can how you denote this as a unit. Then for the time, you have all the natural units like seconds, minutes, hours, days, weeks, years, and days, like this. Then let's come to the events thing. So event is something that whenever you want to log something, whenever you want to emit some point in the transaction. For example, suppose in this case I credited the royalty and you want to raise an event after that. You can just simply say, you can declare your event first, and so this is a definition of your event. What are parameters you want to define in the event, and you can simply say emit my event with the parameters. Just simply like logging we do in the programming language. Then we have function modifiers. As I mentioned, function modifier is the condition assigned on particular function before actual function body is executed. Okay, so this is the definition of function modifier. So you get a keyword called as a modifier, and in this case, suppose I'm just saying that only owner. So only owner means msg.sender equal to owner. Owner is my contract address here. I stored it in my contract. So I'm checking if the sender is owner or not. If he is the owner, then only go ahead. Otherwise, simply don't execute that function. So now this is my function modifier. So underscore is a particular keyword here, not keyword. I would say just an identifier here. to define, I mean, this is just to denote that here is my function body. And this is how function modifiers are actually gets defined. So if this condition is true, then perform whatever that is actually implemented in the function. Okay, so this is my modifier. So now applying this modifier on a function is comes this way. This was my actual function up to here. Okay, I was having this function. Now I want to add a condition on this function that only owner should be able to do this. So just add only owner to this, and this would be applicable to this body. I mean, before executing this part, this has to be true. A very simple thing, but given in a handy way to implement it and use the logic. Then let's come to the libraries. Libraries are, as I said, small piece of reusable code you can define in a separate container. Again, we have a keyword for library here, not the contract. Contract is different, but keyword library is something that a reusable utility code that you can use it in your contracts. So, for example, in JavaScript, jQuery is a famous library. You can use it in any of your JavaScript code by simply including a jQuery file as a dependency. So here I'm declaring my library. In that I'm simply having one function right now, which is simply doing something, which is simply returning the address of this and an address of the current contract. And to use that, I just have to simply say that mylib.getCoin folder. So very handy way. I mean, we know this in most of our languages like JavaScript, C, and others. So similarly, it is implemented here. I mean, nothing very different from the other languages. But yeah, I would say that the language specification is rapidly changing. I mean, you may not be knowing that what will be changed next, because unless and until you are following their GitHub and GitHub issues and the things that they are working on. Otherwise, it will be surprise to you that hey, this is changed now. But that again would not be a problem for you, because if I say that language is rapidly changing, then what will happen to my contract which I had deployed a month ago? So that would not be a problem, because you are actually defining a version that you are going to utilize it. Okay, so on the Ethereum platform, they maintain all the versions which can be used, and they never actually go and delete or remove the previous versions, because you know that some of the contracts might be actually running on that particular version. So if you want to upgrade your contract, you can. I mean, there is no simple way to do that, because once your once your contract gets compiled on the network, it becomes like it has a unique address again, but modifying it is a very tedious task, because all your previous transaction, all your previous blocks might be having some different logic applied to them, and the hashes of the data on those particular blocks would get different if you change the contract. So creating a contract is something like, as I said, creating a currency. For example, suppose Indian government is launching 2000 note today. So they have to prepare for that note, I would say, years before in actually launching it, because we cannot launch a 2000 note today and say that hey, there is some mistake on my note, and from tomorrow the note will be different. That cannot happen. I mean, that's how they're in contracts also. So your contract has to be foolproof. It has to be I would say be able to handle all the use cases, all the conditions over the network. It should be self-protective to the attacks, and self-protective to all the threats that are happening on the network. Like, you should not expose your very private data or addresses, say keys from your contract. So that's how it should be. It should be self-protective. And again, writing the contract is all up to you. How precisely, how securely you write it, and how you make it foolproof for the every kind of attack that can come to your contract or your entity. So for example, in your case, when you say I want to put land records on the blockchain, so in that case, you should not be, your contract should be very protective in terms of the data, the access to the data. So you have to precisely declare what you are declaring as public, what you're declaring as private, and all these things. Okay, and finally, a very simple example for the inheritance and polymorphism. So I'll go one by one simply. So this is my base coin contract, has some logic inside that. Then inheriting from a contract is as simple as other languages. Just use keyword as is, and this becomes your the base class or the base contract, I would say. And this is now my derived contract, which is derived from the base coin. So all the base coin functions and all the members of the base coin are all available to this function. Okay. So in this case, my owner is actually declared in the base coin, but I am using it in a model coin. So that's how it works. You get all the inheritance from your the base class that you're getting. Then you can also have abstract contracts. So abstract contracts is again very similar to the interfaces that we see in C# and Java. So these abstract contracts are nothing but just pure signatures of my contract. So I'm not declaring bodies to them because I'm just keeping the signatures here. And what I'll do is that I'll simply declare them or implement them in the next set of contracts. So Ruby coin is actually implementing coin helper 1, and inside that it is declaring this lookup function with the same signature again. That is the important. And similarly, my gem coin is implementing coin helper 2 abstract contract. It is actually implementing my 2 functions. And again, the rules are same. Whatever there in your abstract class, you have to implement each and everything. If you don't want to implement it, just keep the body empty, but you have to implement. That's the rule. And again, you can utilize the facility of multiple inheritance, like in other languages we have. So iron coin is my new coin, which is actually inheriting base coin and mortal coin. So this chain again goes back. So mortal coin is again now base coin. So similarly, you can, I've declared this base coin and mortal coin again, but you can also chain the inheritance and utilize it. Okay, and uh, if you want to, get an instance of your contract as a part of, as your inheritance uh, uh, dependency, or the inheritance which is actually not the contract but an object of the contract. So you can also do that. You can simply instantiate it, the iron coin here, and make it in as a inheritance to the diamond coin, like this. So these are all the language specifications and the language reference of Solidity. Writing a contract is all up to you, how precisely you write it. And all right, so I'm almost done from my side. In next set of, on tomorrow's lecture, we will be seeing how to actually deploy this. Okay, we have written a code. Now we have a complete set of contract in your hand. You have the code, but how to actually compile it and how to actually deploy it on the network. So that's what we would see in tomorrow's lecture.
So Kaka, some questions. First is that what editor you are using for this one?
This is Visual Studio Code editor.
Code.
I have actually also shared the links to this. Or it's simply called as Visual Studio Code. You can download it from its site. It's very simple setup.
So the same thing which you shared earlier, right? Yeah. Sunil has sent some of the link, right? It's the same thing.
Exactly. Yeah, it is there. And to install an extension in the editor, it is simply just click this curve button here and simply search for the Solidity extension. This one would come on top because it's very famous. Just simply uh, click the install button. This comes here. Right now it is installed, so it gives me uninstall and disable buttons.
Okay, got it. The second thing is that are you going to share the sample codes which you just get to us? So just send us the files for each code.
Exactly. I have created a Git repo. You can simply download it from here. It is all available on GitHub publicly.
Oh,
You
okay.
can simply
Okay.
download it and yeah.
Okay.
So, Kaka, which version of Solidity shall we be downloading?
Sorry?
Which version? Because if I look for the extension for the Solidity, there are a lot of results which are coming. So Solidity and then Solidity language support, Solidity extended.
This is first one by Juan Blanca. This one.
Perfect. Okay.
This will come first because this is quite famous and it has a lot of rating and a lot of downloads. You can see it's almost like 210K downloads for this. The first one is the one that you need to download.
Okay. Thank you.
Okay. Kaka, you gave us a link for MetaMask. So using that MetaMask, are we going to connect to Ethereum?
Exactly. That would come in tomorrow's lecture. I'll tell you how to use that MetaMask and how to that comes under the deployment and compilation part of the contracts when we actually will deploy on the Ethereum network.
Okay, so timing, do we need a gate or not?
Gate.
GETH, gate. Go Ethereum.
Sorry, do I have shared a link for that?
No, Sunil basically earlier was saying that, okay, you need Git client.
Mm-hmm. No, for my set of slides, that is not required. It might be required for Sunil's slide.
Okay. Okay, that's fine. That's all.
Okay, guys, any more questions on the Solidity language? If you want to read anything more about this language, I mean, there are many topics and many other things you can, explore from the documentation. It is simply available at solidity.readthedocs.io. You simply go to this site and get the latest version documentation available.
Could we see what we are going to cover tomorrow?
Yeah, tomorrow. So in my GitHub repo, you will see we actually today saw these three files here. Okay. There is fourth file called as token ERC20. So this is a full contract, okay, which we are going to deploy and create a new currency, our own currency on the Ethereum network. So also study this contract which is there in token ERC20.sl file. So just go through this. I mean, it's not very important that you should understand each and every line, but just understand the basic part of it, like what it is actually doing. Like in this example, for this case, this is the constructor. So previously there was a different way of writing constructor. Okay, so it was in 0416. Okay, so today writing constructor is different way. Okay, today I have a keyword dedicated to constructor. Okay, but this is something that I had designed a few months ago, and I don't want to actually make modifications to it because modifying it is again, breaking. It might break some logic because it is for creating a currency on the network, and that's why I have kept it. And you will also come to know the differences between the versions. And having a previous version is not a bad thing because when I designed it, this was the latest version. So this code will still run as it is without any errors or without any limitations of not being on the latest version, because I'm pointing to the exact version that I've written it. Okay, so just go through this and just try to understand. I've written all the comments wherever possible, and you will also find this code as a standard code over the internet, because this is the code that also recommended by Ethereum guys, uh, whoever wants to create their own token or their own currency over the Ethereum network. So they have recommended it. They have authorized this code. Like this is the way that it has to be when you want to create a new currency, because a currency is a very common thing. I would say it's the only common thing on the Ethereum network, and rest of the other things comes under the private blockchains, because you won't be able to. I mean, you should not be going to Ethereum network and put the land records on the Ethereum network, right? Because max to max what you will do is that you will create your own currency on the Ethereum network, and you will put it on some exchanges for trading that currency, because currency trading is something that you have to put it globally, because uh, people should be able to buy your currency. That's when you can earn, right? So this is that's why we have ERC 20 standard for the tokens. So token means basically a currency, and ERC 20. So 20 here means the 20th version of the token standard, and there that's why it is named as ERC 20. But this ERC 20 doesn't actually uh, you know implies to you that you should always name it as ERC20, but just since the whole code is from the Ethereum guys, they have named it as ERC20 because uh, that's the version they had prepared it. Okay, because you can always rename this particular contract or the uh, constructor to your own name. You can put it to your whatever name that you want. Okay, but just when you're creating an instance and just when you're deploying it, there comes an option to supply the name of the token, symbol of your currency, and the initial supply. So I'll explain all these points to you when we will actually deploy this contract.
Okay, so tomorrow means we'll create our some network. We'll have some gas, and we could do some transaction.
Exactly, yeah. So all the
Yeah, that will
practical
be great.
work that requires on the Ethereum network. So like doing it on the live network would cost me some ethers. I will have to spend some actual money for it. So for that, there is a provision from Ethereum network itself that they have created a test network, which is like dev network. You can simply get some free ethers on that network. You can deploy your contracts. You can see your new currency, but the only change or the only difference is it is on the dev network. So like any other platforms, they also have a dev network where everything is free. You can get free ethers, you can run your contract, you can test it, you can transfer the currency to other address and see how it works. And when you're satisfied with your contract, and you get a confidence that yeah, I've done good logic in my contract now. So post that you can get the code and deploy it on the live network. It's very similar to like what we do usually in our projects, like staging environment and the production environment.
So, Kaka, basically on MetaMask, there was option give your
Mm-hmm.
password, and it was generating some ID. So that ID was my public key. Is that under some either test environment or dev environment type of thing was there, as I remember.
Yeah, these keys are definitely different on the dev network and the production network. That's the main thing. I mean, address on your dev network would be different, and address on your actual production network would be different. So yeah,
Okay, so
as you
assuming
said that
you
these
and
will be
me
different. Yeah.
both are creating two IDs on MetaMask on dev environment, then
Mm-hmm.
after adding some ether, we can send money to each other on dev environment only.
Yeah, yeah. Only on dev
Is acceptable?
environment. Because the whole environment is different. Whole network is different, and the production network is different.
Okay. Just I have one more last question, not related to this solidity. So, assuming there is one transaction passed, Sunil has sent Kaka $10. So, 1 month back or 2 months back, whatever, and that transaction is now in blocks, and now many blocks has been created.
Yeah.
Now, assuming I want to search, Sunil has sent Kaka to $10.
Exactly. I mean, I'll tell you how to track your particular transaction on the network. So network actually keeps the complete history of your each and every transaction that is happening on the network. So whenever you are submitting a transaction, you get a unique transaction ID or transaction number, and which is very unique for your particular transaction. You can also see all the transactions that are happening on the network because they are kept open, and you can see who is actually transferring how many amount to other guys. But the only thing is that you will see the address, and by the address you cannot judge who is the guy. Okay, the address is just simple unique string of numbers, and based on that you cannot guess, or you can, there is no way to track down the real person, but you can see the addresses and the transactions.
Okay.
Just can you please share one more time that link where you have that sample code? I just want to note it down.
Exactly. Yeah, I think this presentation is will be shared with you guys, or
they share it. I think after a few days. I just want to note it down.
Okay, sure. So you can just go to GitHub, then /nfiles, and then blockchain. If you directly go to github.com/nfiles, you will see my repositories, and you can go to then blockchain training repo. Yeah. So just go to github.com, say nfiles, and there are all the files. In the sample code, you will see files.
Okay, thank you.
Yeah. So guys, any more questions? I think we have taken 20 minutes more, but yeah, let's see.
Okay, thanks, Kaka. From my side, see you tomorrow.
Thanks, Kaka.
So,
Thanks, Tony.
Okay,
thanks, guys. Bye. Hello. Hello.
Hello, Ashok. Actually, Sunil texted me that at 9:30 he left and he informed Kaka, and Kaka was giving training. So, Nagesh, Sunil, can you hear us?
Looks like they also left.
तो इसको मैं बंद करता हूँ तो रिकॉर्डिंग वो डाउनलोड कर लेता हूँ फिर
हाँ, yes.
ये भी आ जाएगा अभी जो बोला अभी